Good morning, everybody. Good afternoon. Thank you very much for joining today's webinar about proxy voting. I'm delighted to be joined today by our partners at IntellectEU. We're going to be talking about simplifying and improving the processes around proxy voting using smart contracts and distributed ledgers. We have a live demo today of an application built by IntellectEU running on our Daml for Corda smart contract integration layer. I would encourage people, please, if you have questions, to use the Zoom chat feature, which if you move your mouse, you'll see at the bottom of the screen, there's a little speech bubble with chat written by it. If you tap on that, you can feel free to direct your questions to any of the panelists directly, or perhaps to the whole room. I'll be watching that, and I will be flagging those questions up for our speakers today. If you do that, we can keep it running. We would like to make this interactive though, so please, I do encourage you to ask your questions. Yep, we're looking forward to getting going. So in terms of our agenda for today, I'm going to talk briefly about smart contracts and Daml for Corda itself. And then I'm going to turn over to our colleagues at IntellectEU to talk about the challenges of proxy voting, some of the operational difficulties that arise with that, and how distributed ledgers and smart contracts can help to alleviate some of those. And then followed by a live demo. So in terms of who's talking today, my name is Tim Kemp. I'm the head of emerging ledgers at Digital Asset. My team is responsible for integrating Daml, our smart contract language, on a variety of distributed ledger platforms, including Corda, Hyperledger Fabric, Sawtooth, Besu, and also some non-distributed ledgers like Amazon QLDB and SQL databases. I'm joined today by Luis Morado. If you'd like to introduce yourself, please, Luis.
I'm one of the technical leads at IntellectEU, specifically focused on everything related to digital assets. As part of my activities as a software engineer at the company, I do consultancy with clients on different projects, not only related to Daml, but in distributed ledgers as a whole. I have a background with IT, of course, and I've been working with integration with legacy systems for pretty much all my career, and that's pretty much it. So I will now probably pass the word to Thomas to give his introduction as well.
Thank you, Luis, and thank you, Tim. So I'm Thomas. I'm heading the blockchain and DLT solutions team at IntellectEU. This means I spend most of my time working together with our blockchain and smart contract partners. Two very important ones are, of course, Digital Asset, where we have a strategic focus on using their smart contract language Daml in our products, as well as R3, the company that delivered Corda Enterprise or Enterprise blockchain of choice, when we work together with mainly financial institutions. And so that's a second part of the of my day-to-day activities, working with our larger client accounts, being it CSD, stock exchanges, and global investment banks, on providing blockchain consultancy and professional services. And then next to that, I work very closely together with our product team, where we have the Catalyst product suite, a blockchain managed service and software platform that we might touch upon shortly during this presentation as well. And my background has always been in finance and financial technology. So back to you, Tim.
Okay, great. Thank you very much, Thomas. So if we could move on to the next slide, please. I want to talk a little bit about smart contracts. So I think most people now who've read business press, been around technology for a while, are familiar with the promise of distributed ledgers and blockchains. These are mechanisms which make it very easy for multiple parties with varying degrees of trust between them to agree on what is actually true, what's a statement of facts that we can all agree on about the state of some business process, or the state of the balance of an account, you know, a ledger of assets being exchanged, or the state of the, you know, the contents of some database somewhere that represents inventory. The underlying technical mechanisms of blockchains and distributed ledgers make that possible. What they don't really talk about, though, is what are the rules for how that state should change? And that's where smart contracts come in. So I'll give you an analogy for the moment. If you think about playing a game of chess over the mail, so postal chess, as used to be popular before email, or even email chess, you've got a mechanism there for keeping synchronized two different boards. If I decide to play chess with Lewis, which was probably be a bad move on my part, but if I did that, then Lewis and I would both receive each other's letters in the mail. We'd open them up, we'd read the moves that each other had made, and we would update our own boards accordingly. That's essentially analogous to the blockchain or distributed ledger piece. But what about the actual rules themselves? What governs how those pieces can move? That's more about where the smart contracts come in. So if you think about the game of chess, you have a pawn which can move in a forward direction, which can take diagonally. There's a little exception to that rule called en passant. You have knights that move in an L shape, and bishops and queens and so on. You take it in turns to make moves. There's certain point values when you take a piece. There are rules that occur when certain special situations arise, like you get in check. Those rules there can be governed by something called a smart contract. So the smart contract is a mechanism for controlling the allowable set of states and how they can move from one state to another on a distributed ledger or blockchain, or really just any sort of place that records state, any piece of infrastructure that can record a fact, so even a database. So a smart contract is, that whole set of technology came about with the advent of blockchains and distributed ledgers as a way to control the evolution of information on those. What we've been finding at Digital Asset is that there's enormous interest in using, there's enormous business benefits in using smart contracts to help, as the title says here, construct or bridge islands between silos in institutions and enterprises, so between different desks at a bank, for example, just as much as there is between silos external to the institution, so between vendors and suppliers, between banks and the brokers and their trading counterparties and so on. So smart contracts are a way to make that happen. Generally, in the case of blockchains and distributed ledgers, the way that you create those smart contracts is you write code in a traditional general purpose programming language. You might have some extensions to JavaScript in the case of Solidity. You may be using Kotlin or Java or JVM based languages if you're writing smart contracts for a Corda based blockchain. If you could change the next slide, please, Thomas. At Digital Asset, we looked at that problem not from the perspective of the creators of a distributed ledger platform, but rather from the perspective of somebody who would want to write a smart contract to control and govern a business process. So we created from the ground up a domain-specific programming language called Daml. It stands for the Digital Asset Modeling Language, although we prefer these days that we just call it Daml. It's its own word. Daml is a programming language created specifically for controlling the evolution of information on distributed systems. It's a perfect language for writing those rules, for describing the the interactions of pieces in a game of chess, or for controlling the roles and responsibilities of the different parties involved in a proxy voting process, as we're going to see in a bit. The way that Daml works is that you write your application, you write your business application, your code in Daml. That Daml runs on a runtime, a piece of software here represented by that block in the middle, the Daml runtime in the Ledger API. That runtime talks to an integration. The integration layer then speaks to an underlying distributed ledger or database. So there's that set of boxes there at the bottom, all those logos describing the various different platforms on which Daml can run. The interesting thing about Daml here is that a piece of code that you write in prototyping mode on day one, targeted to run on a Postgres database. There's no distributed element there, right? It's just Postgres. You can take that Daml code and without changing a single character of it, deploy it on a Fabric distributed ledger to prove your concept out to a wider audience and perhaps test it out with multiple parties. Then when you're ready to move it to production, you've got your choice of ledgers with certain privacy guarantees. You can pick a distributed ledger which makes sense for the characteristics of your use case. You can deploy that on Corda Enterprise if you want heavy support. You can put it on VMware if you want backing from that firm, and so on. So the Daml code stays exactly the same. The way that your application interacts with it through the Ledger API, your website or your service or whatever sends calls in through the Ledger API, the runtime, all of that's the same. You just change the integration, change the underlying platform, and your Daml code is fully portable and runs on any of those underlying platforms, with more coming. The one platform that I think is of interest for our webinar today, and the one that which Luis and his team have built the proxy voting demo against, is Corda. Daml for Corda is an integration, just like in that previous box, which allows Daml code to run on any flavor of the Corda Distributed Ledger. It works in an enterprise context on Corda Enterprise. If you want support from R3, the additional features in Corda Enterprise, it works fine on that. If you just want to get started, if you're supporting yourself, if you're prototyping, what have you, then it works exactly the same way on Corda open source. Daml has a number of additional ancillary benefits that it brings above Corda. The language itself supports sub-transaction privacy, blinded transactions, so the operator of the network is not able to see the content of your smart contracts or the data that you're transmitting across it. As long as you interact through the Ledger API, Daml will provide that guarantee for you. And then the other semantics of the Daml language itself, which I'm not going to get into now, but we can certainly welcome to talk to anybody offline about that. And Luis will be touching on some of that in his presentation too, about offer accept patterns and insurance of consistency and correctness of the code that you're writing. Just to wrap up all of this, the promise of Daml, with a specific language built just for creating smart contracts, there are no concerns about the system, no management of keys, no need to worry about how you send messages or how you persist state to the underlying platform. That's all done for you. Daml gives you a significant increase in productivity in terms of how fast you can get your application built. Being a very narrow language focused entirely on the business domain and the rules that you're writing for your application, you can turn out you can turn out a functional application much faster than you would be able to on something like Java or Kotlin or JavaScript, where you have to worry about all the the systems mechanics around the side. Runs on a variety of platforms, and in Corda terms, it runs on enterprise and Corda open source. I think that's probably enough from me. Again, questions, please put them in the Zoom chat. If there aren't any, then I'll turn over to Thomas, and I think we can get started with a specific example of how Daml is used to create a piece of viable business functionality here in the proxy voting domain. Go ahead, Thomas.
All right. Thank you very much, Tim, for that introduction. So what we will be trying to do with IntellectEU, Luis and myself, for the next 30 minutes or so, is we want to dive a bit deeper into a specific use case named proxy voting for the capital markets. We will touch upon what are today some of the challenges that we see in that market. How could blockchain and smart contracts, more specifically Daml, potentially help in solving these problems? And then we will dive into the actual demo and also technical architecture on how we have built this proof of concept. Now, with everything that we say, I would like you to think of this as a broader problem that we see in financial services, in capital markets, in the insurance industry, but even in supply chains and logistics, where a lot of different participants are looking at a specific piece of data, and on top of that data, they're trying to implement their business processes and continuously reconciling with each other. And proxy voting is a very nice example of such a process, and that is why we have chosen this one to showcase the Daml on Corda demonstrator. I will keep it very high level for what proxy voting exactly is, as I see most of the people in this call are also from the capital markets and investment banking industry. But so in general, at the highest level, proxy voting is really the process where there is a ballot cast by a person or a corporation on behalf of another shareholder or a corporation who might not be able to attend a shareholder meeting. Now, in this specific example, we're speaking about issuers, so corporations who are traded on public markets. So, for example, a company trading on the NASDAQ or a company trading on the New York Stock Exchange. A potential issuer could, for example, be Tesla. Now, what happens during shareholder meetings? They have to decide on certain things. This can be, for example, are we going to do a stock split? Is there going to be a merger and acquisition? And so these votes, these proxy votes, can have quite a big impact on the financial structure of the company and the long-term viability and future of it. Now, one example, what do we see happening with proxy voting? Often the biggest shareholders of companies like Apple, of companies like Tesla, are the big funds, the big investment companies, and they might vote on behalf of actually the shareholders, the individuals. So we're here looking at the investment managers and or the asset managers. Now, the proxy voting process itself has four main blocks. First of all, there will be an announcement from the issuer that there is a certain topic that needs voting. There will be interaction with the customer on the agenda. There will be the process of voting itself, and there will be the confirmation of results. Now, within this process, we see a lot of different steps and, even more important, a lot of different stakeholders. So there is a very long holding chain from where the information is going from the issuer itself to the actual voter on the ballot. Now, who do we have in between? So first of all, it starts with the issuer, who will communicate to the local custodian, who will communicate to the global custodian, who will communicate to the central securities depository, who might communicate to the international central securities depository, as an example, a DTCC or a Euroclear, and they will then communicate it to the asset managers. Now, today, how does this communication happen? Partially is still paper-based, so manual. Standalone tools and proxy services are being used, message-based networks, all in different formats, looking at different data. So we now understand the process of proxy voting. We know it has using different tools, different formats, and a lot of different steps and stakeholders in between. Now, all of that brings some challenges. First of all, as I said before, for example, on a merger and acquisition, it can be quite important, the impact of the vote. Now, what we see, because of the different standards, different tooling, different communication layers, like often there is the risk of information being lost. At the same time, there are also deadlines that need to be met. There is the cutoff date for a specific vote. Now, if that deadline is not met, that vote is not counted, well, those votes could have a big impact on the actual decision. Now, what we also see is that because of the inherent structure of how CSDs and stock exchanges refer to shareholders, with omnibus accounts, with legal versus beneficial owners, not always the voting comes to the actual end shareholder, the individual, but the voting happens in bulk from the asset manager, and so they're hiding the actual shareholder. Now, with all of this, of course, we have an inefficiency that we have created. We have a lot of costs that come with it because of the messages, the tools, and the intermediaries, and we have the need for continuous reconciliation between all the participants included there. Now, what is the business process? So the business process which we are envisioning and which we are also going to show during the demo, so I will run very high level through this. We will show a meeting creation. We will look who is entitled to vote and send that to the local custodian, send all the data in a standardized format over the voting instructions, execute on top of this voting, confirm and share the actual results. Now, we will do that using Daml as the smart contract layer, the programming language, and we use Corda underneath as the distributed ledger to share the actual data between the nodes, between the intermediaries. What kind of benefits and advantages do we want to bring with this? So first of all, because we now have a solution where we have a single place of communication, a single place of information, in the distributed ledger in the actual persistence layer, we are now making sure that we have a golden copy of the data, and we execute on that golden copy. Secondly, because we use Daml and we have standardized and partially automated the workflow, we have a deterministic outcome, and we directly link the shareholders with the actual issuers that create the meeting. So we're able to automate partially deadlines, notifications, and updates with direct communication. We provide more transparency and trust into the system that you, as a shareholder of a specific company, that your vote will be counted, and you can also look and track back how the voting has happened. Because we streamline the operations, we reduce the need for reconciliation to the bare minimum. We can also have big savings on costs because of partially that automated reconciliation. And because of the blockchain, and definitely with integrations and in a broader financial infrastructure, we're able to comply to SRDI, the Shareholder Rights Directives 2, a new directive that makes it obligatory to really pinpoint the beneficial shareholders as well. Now, I want you also to look at this a bit more in a broader sense. So this particular solution could, for example, be used centralized. Look at a CSD that might implement this to communicate with their participants. It might be a local or a global custodian to communicate with their asset managers. But where we, with IntellectEU, really see the value is by building a fully end-to-end decentralized system where we leverage the workflow part together with the blockchain DLT Corda enterprise part. Now, if we want to zoom out of this, we see that proxy voting is very similar as a lot of the corporate actions. And actually, what is corporate actions? It's a multi-party workflow with multiple stakeholders where we want to create a deterministic outcome whilst standardizing a certain process or business workflow. So this solution could easily be expanded to other communication layers between financial intermediaries, starting from the issuer. Now, if we then zoom out a bit more, we can really start thinking about smart financial products. What if we issue directly bonds, equities, derivatives on chain, modeled in Daml, and then link these actions like proxy voting, like corporate actions, directly to the actual financial product. And that is a vision that we are also creating with IntellectEU and with partners like R3 and Digital Assets. So creating this trust and efficiency into the network. Now, I will not any longer keep you waiting and pass the mic to my colleague Luis. We will go a bit deeper into the technicalities and then showcase you the actual demo that we have built.
Yes, thank you, Thomas, of course, for the presentation on the use case and also on the broad scene that exists. So we're not definitely targeting just this use case. It's more than that. But focusing on the technical overview for the Daml on Corda. So this is a little bit of an architectural view where we can see the containers that this solution has. So your common Daml applications, in essence, will connect through the standard Daml Ledger API that will then connect to a Corda adapter that finally reaches out to the actual Corda node, and where a Corda app, a specific Corda app for Daml should be installed and deployed. And then as exercises and creations of contracts are pushed through the Ledger API. They will, of course, be notarized through the notary service from R3. They will reside on the vault as regular states. Then, of course, if that state is evaluated that needs to be shared across nodes, the communication happens in a standard way between, as it's regular within R3, between the core apps as part of the workflow that has been defined. All right, so moving a little bit closer to the demo in this case, and showing a little bit, just a very brief snippet of the architecture. So for the demo, we're just providing 2 nodes. Okay, so in essence, the use case on proxy services, proxy voting, sorry, that we're going to show, there are multiple parties interacting with it, but within each Corda node, we allocated specific parties as demo parties that have access to that node. Okay, so this is the way we've separated things. So for this demo, where in one Corda node, we have the regulator, the issuer, and the CSD that can connect and view the contracts that reside at that node. And on the other node, we see the proxy services, voting party, and the local and global custodian. All right, so this is the basic setup, and I'm going now to start moving to the presentation, to the demo itself. I should be now trying to share my screen, hopefully. Okay, let me quickly, okay, this one. Hopefully everyone can see the screen. So at this stage here, I just have 2 navigator windows. So this is going to act as my UI for this use case. Behind the scenes, I already have my Daml on Corda network running. Okay, so with the 2 nodes, I've already managed to deploy, and this can be shown, the contracts and allocate the correct parties at each node. So on this first navigator, we see the parties corresponding to the first node we've created. And on this other navigator, we see the remaining ones. All right. So first thing, for this setup, this current network is clean. So in essence, apart from the application that has been deployed and the parties that have been allocated, there are still no contracts. And as it is a general practice within Daml applications, it is usual for some basic setup of contracts to be created before we actually delve into the more standard workflows on the use cases. And for that, I prepared a few scripts that we're going to see acting behind the scenes, and then we can see how the contracts show in the navigator. So the first contract I'm actually going to push through this script is going to be triggered by the CSD. So right now, this is empty as we see it, and I'm going to, behind the scenes here, create or execute the first script, which will basically trigger a couple of contracts, a couple of proposals that follow the pattern of an initiate, accept, design pattern for Daml, and we'll create those 2 contracts from the CSD to an issuer and to voting parties. Okay, in this case, we just have 1 in this demo that we'll be showing. But what we'll be able now to see in a few seconds is that a few contracts hopefully will appear here under the CSD. In the meantime, because sometimes this shows a little bit slowly at first, hopefully things will work out. Okay, so a few more seconds while the system seems to be warming up. I'm checking if everything has worked successfully. It seems like it has. So just refreshing just in case. Okay, here we have. So we have the 2 onboarding proposals that the CSD has sent across. So we see right now we're on the first node, okay? And we have one of the contracts is between the CSD and the issuer. So no information in this case has gone from this first node into the second, because the issuers is maintained as an allocated party within the first node. But in the other case, where the voting party is the new participant that is invited to onboard, we will actually see here, okay, seems to need to refresh consistently. Okay, And here we have the onboarding proposal. Okay, so we already see a glimpse of the system working, and we have the segregation between nodes, of course, because we see that certain information was sent out or created within the first node and shared to a second node. This, in this case, specifically for the voting party. All right. So with this first script that was triggered, we now need to push for some other parties to do certain other actions to fulfill the setup. In this case, we're going to trigger the voting party to invite a set of partners, which each of these partners will be part of the custody chain, what we call here the custody chain, which just links how that voting party is connected to a local, global, or proxy services. Okay, so in the case that when a general meeting is agended, is scheduled, then it's needed for the CSD to send out an entitlement for a specific voting party. And with that knowledge on who are the partners for this voting party, or who are the entities that are part of the custody chain, it's easier to transmit that information. But again, all this has to be set up in the beginning. So this is not something that we jump straight forward. We need to push certain contracts as part of the modeling that create these relationships, or in another way, what we call the disclosure contract, the relationship disclosure contract. Okay, but so again, this is again a proposal. So it has been the voting party which has proposed to those other global custodians, local, and so forth, to accept. They have proposed a partnership in this case. So we will take a role during the proxy voting based on this, and each of these parties will have to accept. Okay, and as we do that, so we'll probably be seeing that certain of these contracts will start becoming partner contracts instead of partner proposals. So this takes a little bit longer eventually. So as we're doing some more, let's wait a little bit while it runs. Okay, here we see one of them has already changed, but this is a more global view on the voting party, so not necessarily on the CSD, on each and specific entity. Okay, let's wait a little bit longer, see if things update. Just checking how the scripts are running. Still running, so we'll take a little bit longer. In the meantime, so one of the things that should have happened here is that as part of the scripts, the issuer might already, yes, so the proposal, the onboarding proposal that was sent out by the CSD was already accepted as well by the issuer. So this onboarding proposal will allow the issuer a set of rights. So in such of these rights are the creation of a meeting, then to send out the results as the results become available for the issuer. So some of these things are only possible when both parties, the CSD and in this case the issuer, sign up for this contract. I guess things should be pretty much over. So expectedly, we've given enough time. Well, there's still one that hasn't executed successfully, it seems. Okay, it's wrapping up as we see here. So now it's updated successfully, it seems. One other thing that we are able to see is that these partner contracts become visible for the CSD as well. And why we've done this in this particular exercise that we did was that we wanted to emulate the CSD doing a due diligence on the entities that work with the voting parties. Okay, so in order for the CSD to work with multiple local custodians or proxy services, they need to explicitly approve their entry into the system. So actually they will have a right on the partner contract to approve. And that's what's going to happen next. It's the final step on these scripts that I'm executing. That is going to take these contracts and create a more broad partners contract which has the full custody chain. So we are able to match the voting party to each individual entity with which it works on this use case. Okay, we should be running soon enough, hopefully. In the meantime, I can already share on the other parties, we see the individual contracts. So even if, for example, the information is stored on the node, and the node is a single instance where multiple parties, the allocated parties, connect to, the actual truth is that they cannot simply go at it and read all the information, because unless, of course, they go directly to the vault. But even then, as Tim has mentioned, that data is blinded, so it's not easily seen by any party, even if they have direct access to the vault. But nevertheless, so hopefully this has ended. Yes, we have here the single partners contract, and the relevance for this contract is this is going to be leveraged in both the voting and the entitlement actions in order to send out the information between all the custody chain, as we'll see next. Okay, so having this set up, I will now start really by generating. As an issuer, I will create a meeting. Okay, so as Thomas has mentioned, so we'll create a general meeting where, as part of the details, I could set the agenda for a stock split, something like that. So they're going to vote whether a stock split will happen or not. I'm just here going to push who's the regulator here. So who's the regulator with which I'm going to share this information? Just need to copy this here. And hopefully, yeah, you see there, this action has occurred successfully. So as we do this, this means that this contract for a meeting that was just created from this onboarding contract is available on the issuer, and will also be available in this case for the CSD and the regulator. Okay, so at this stage, this meeting has been shared just with these two entities. As the CSD is now, he knows about the meeting, it can immediately inform, having eventually the information on the beneficial ownership of the shares, it can inform each voting party on the entitlement that he has for the vote. So to do that, he needs, of course, here to push, to exercise a new choice within the meeting contract, which he will explicitly say which is the party that is giving the entitlement to and the number of votes. And when he does that, so what is going to happen is that a new contract for the entitlement is created, and this contract is shared to the second node to actually all the parties that exist there, because despite we having just input the voting party on the choice, by using the contract that sets the custody chain, the CSD is able to share or to define exactly who are the parties who have the visibility on this entitlement. So instead of the cascading of messages that needs to go step by step through the custody chain, we can deliver this notification in one swoop. Okay, so that's really the use case here that we're trying to, the real benefit we get from what we're showing here. So we see the global custodian has visibility on the entitlement, as well as the services provider and the local custodian in this case. Okay, so moving forward, we have then the voting party that does indeed have, he does have to vote or give his instruction given his entitlement. And to do so, all he has to do is give his instructions, which he can say just vote for. Okay, he will create a contract, and in the inverse way, so instead of going into from the CSD into to the voting party in that direction, we get now a new contract that flows in the inverse direction. However, this contract on the meeting instructions does not reach the CSD, so it stops in this case at the local custodian. It's only available to the parties which are part of the custody chain till the local custodian. And this happens because then, as part of the workflow we've defined here, that local custodian, when the date comes for the meeting itself, because these instructions can be set out previous to the meeting, it's when the execution of the vote will actually happen. And for that, the local custodian will need to act specifically and deliberately on the voting execution. All right, and as he does that, this voting execution, this confirmation on the execution will be shared not only to the local custodian, but to the voting party. And of course, this execution will also be shared to the issuer itself. So here, with the voting, with the execution, the issuer can now really accept the vote. So say explicitly again, everything is all right with this vote. It has gone as expected, and just simply accept it. All right. And as we do this, the one last step is that the issuer would collect all the votes. In this case, in this demo, what we're showing is just one single vote, of course, and would send out, sorry, it's not this contract. It's not this, the meeting one, and would send out the meeting results saying, since the voting party that was on the system voted for, so the results was that the general meeting agenda points were approved. Okay, and we just need to set here, again, the regulator to inform him on the results of the general meeting. All right, and this marks the end of our demo. It's important really here to reference that, again, this application, we've actually delivered or first implemented it to run with Daml as well in a centralized system. And through this work that we did, what we understood was that it was very simple really to port the application into a new ledger like Daml on Corda. Okay, so again, the important message here that we think it's relevant to deliver, it's that it doesn't matter too much what is your governance model for the application that you want to build. It's important to share the information across different entities. Then exactly, if there's more centralized or decentralized way that you want to govern as these applications, Daml does provide you with that flexibility. So if you want to go centralized, it's definitely a good option to go with either Daml or SQL, some SQL database, some standard SQL database. And if you want to go decentralized, definitely Corda, and specifically if you're an enterprise, a big enterprise which has many requirements related to security, privacy, it's definitely Corda the top choice. And in particular, if you're really keen to have all those capabilities that enterprise delivers, it's definitely the go-to option with any solution like this. Okay. All right, so on my part, I think I'm pretty much over. I would pass the word either to Tim or Thomas to continue.
Thank you. Thanks very much, Luis. Thank you for the comprehensive demo. So your last point actually is a nice segue into the first question that we've got from Emmeline Denis, and I'm sorry if I'm saying the name wrong, which is, specifically about regulatory change. What's required to actually get something like this implemented? You touched, Luis, on the fact that if you run this on a centralized service, we have the options of doing that with Daml and Postgres, all of which is good and doesn't require much change, right? It's just a software platform change. But Emmeline's question is, how do you consider the adoption of this technology on a widespread basis achievable without facilitating changes in the regulatory framework? And I'll drop in a quick answer, which is yes, in terms of Daml, but not in terms of decentralization. Let's get to that in a second. Second part, what are your views on changes that would be desirable in the regulatory framework to allow and fully exploit the use of this technology for proxy voting? And to what extent has this technology been adopted by the leading and largest companies involved in providing proxy voting services, including Broadridge and Euroclear? So I'll hand over to the IntellectEU team if you want to have a stab at that question. And then we've got a couple more.
Yeah, most definitely. Thank you. So first of all, to touch upon a part of it is we definitely see that regulatory barriers to build a solution like this as a global solution are still there. Like there are local legislations, there are different interpretations, but where we see getting a lot of traction with these kind of solutions are to implement them locally first, with becoming and growing globally and interoperable over time. This is not only for proxy voting, but for example, with IntellectEU, we have also been very active in the know your customer space around data sharing, but also around post-trade processes. And what we truly believe is that the combination of really these technologies, where Daml can create a standardized workflow on how we process the actual data, and then solutions like Corda that can create the interoperability through, for example, the business networks and the Corda network that they already provide, that we will be able to grow that globally over time. Now, also from our experience, we have been working a lot together with the regulators, and we truly see that regulators are open to this. We see things moving pretty quickly in Asia, most definitely. For example, Singapore Stock Exchange has already been looking into proxy voting, but also in Europe and in the US, we are in communication with indeed institutions that are using these proxy voting services, like the ICSDs, the big stock exchanges, and the regulators, into mutualizing the legislations and into facilitating the changes in these regulatory frameworks.
Okay, thank you. There's actually a follow-up here from Jacques Liep, who would like to know about compliance with SRDI. I can read the whole question out, Thomas, if you like. Yeah. So since September,
so this solution, I can answer a little bit. So this solution, of course, as a demo that it is, it doesn't follow fully the standards, the ISO standards in essence. But as IntellectEU, we're actually Swift partners. We've been working extensively with Swift for over 10 years, and we do have knowledge on the ISO standards and know how to apply them. Even on the work that we've done while first analyzing this use case, we considered whether we wanted to push forward already something like that, but in the end we decided just to opt for a more simplified process here, just to show the value, because we saw, of course, that under a demo, so this is not to take for production right away, it would have to be somewhat reshaped. It's then on the data model that we need to change things. So certain actions that we exercise during the demo, instead of just pushing for some simple information fields like we did, we would have to fill out all the fields that come from the ISO standards. So that's pretty much what would probably happen. Of course, there are certainly caveats that we need to handle as we do that, but as part of the work we did, it's definitely possible. And it's something that we would definitely be looking forward to provide as well.
Okay, so primarily a matter of expanding the schema, basically adding the additional fields to ensure compliance. Okay, from Christian Wilk, how do you ensure that all parties along the custody chain use a Corda node compared to today's Swift standard?
Yeah, so definitely. So I think that also comes a bit back to what Louis was just saying. So we truly believe that the ISO 20022 standards that are being put in place are creating a lot of value and are very compatible with what we can do with Daml and with Corda. One of the live examples that proves that is what Digital Asset is doing in Australia, for example, where the full implementation of the new chess platform is ISO 20022 as well. As well, we believe that these kind of systems should be open, interoperable, and integrate with the existing infrastructures. These can be the existing infrastructures of the banks, of the market infrastructures, or networks like, for example, Swift. And then indeed, if we want to create that true end-to-end efficiency, we have to move to a system where most of the big organizations are running their nodes themselves, so their Corda nodes. Now, what we not expect is that every bank in the world is going to start running a node specifically for proxy voting or specifically for corporate actions. But this comes a bit back to the bigger vision that we wanted to share there, as these markets are moving from electronic and message-based communication to more transactional-based and digital markets, we see the appetite of financial institutions and market infrastructures to run these nodes and create an end-to-end workflow from the issuance of financial products to the trading, the settlement, the post-trade, and then the asset servicing, including the proxy voting and corporate actions as well.
So, great. Sorry.
Yeah, I just wanted to add a brief reference. So as part of the work we've done, so not to focus solely on proxy voting here. So we've looked at different standards. So currently we're actively looking at is the standards like CDM and FPML, and working actively in projects that relate to it. So it's not just, of course, these standards that we look for. Then we do invite, or we push our customers as well to take these standards when applying them in their applications, in their real world use cases.
Mm-hmm. Good. Yeah, I think I just want to pick up on something that Thomas mentioned before. What we're doing with the Australian Securities Exchange is exactly that kind of hybrid model, which is the way that these things get adopted over time in large and complex financial networks, which is you have a central operator, a regulatory mandated authority, which is looking after the network, and you bring you give parties the ability to operate nodes on that from as early as they would like, but you provide a level playing field legacy access model for those parties that are unable to do that, and you gradually allow people to switch over over time as they get comfortable with it, and as the network matures and their technology budgets and appetite can catch up with that need. For the benefits of governance and control over smart contracts, for the business aspects of this are really the same whether or not it's fully distributed. There are additional reconciliation steps if you're not taking a node on the distributed ledger, but the actual control over the evolution of that data is the same regardless. So there's a question here from Jean-Claude Chavot, which is, how can such a proxy voting solution also help solve the challenges of computing the beneficial shareholder ownership and voting rights of shareholders in passive investment and index funds?
Yeah, so I think it also relates a bit back to the SRDI that we stated on before, right? So once we have a distributed ledger in place where directly we can see who exactly the legal owners are and the beneficial owners in a shared environment as the single source, the golden copy, we can then leverage Daml that can automatically calculate and execute on looking who is entitled to vote, who are the beneficial owners, and how do we communicate to these beneficial owners the right amount of data with that sub-transaction level privacy. So I would say exactly this kind of solution and the combination of these technologies, that is exactly what it could do in a secure, distributed, and private manner.
Okay, thank you. I just want to pick up on Emmeline. The last part of the question there was, to what extent has this technology been adopted by leading and largest companies involved in providing proxy voting services, including Broadridge and Euroclear? I do want to point out that Broadridge is a user of Daml, and they're using that technology in a distributed fashion on a distributed ledger for providing tri-party repo services. So yeah, they're enormous in proxy voting, as everybody knows, a key component of that infrastructure. But they have been exploring the technology and are now using it in a different area. We would certainly hope that they consider it for proxy voting in future. The point there is, that the company has adopted it and is making use of it, but touching such a critical part of their business is not something that's undertaken lightly, and certainly not as a pilot project. Okay, James Jaworski would like to know if the demo is going to be published on the Digital Asset GitHub. We didn't write it, so it's really not for me to say whether it has a future in open source or not. And I will put IntellectEU on the spot, but feel free to defer the question if you haven't decided yet.
I think I can answer this one. So as a default for now, we have a couple of videos really. So one of them is just the use case, kind of like we've shown here with Navigator, with Daml Navigator showing the contracts. And we have actually, or we're going to push another video within our YouTube channel where we're using Daml and we have a specific UI with it. So that's, you definitely invited to check out our YouTube page at IntellectEU, and you should have visibility on this use case.
Okay, great, thank you. So I think we have covered all of the questions that people have asked. A couple of people asked some more technical questions, which I dropped in text answers in the chat channel. So for Georgi and Bart, if you're not able to see those, please let me know. Follow up directly with me afterwards if you like. Otherwise, we have reached the end of our agenda. I want to thank everybody again for attending, for the excellent questions and the good discussion. I definitely appreciate it. Thank you to IntellectEU also for contributing expertise and for working on the demo for this. And for being such great partners of ours with Daml as well, and for believing in the technology. So thank you all. Thank you very much.
All right. Thank you for having us as well, Tim, I guess.
Of course. Always a pleasure. Sure. Okay, and also he's unsung and behind the scenes here, but many of you know Manish Grover. Thank you very much for organising this today, Manish, and herding all the cats and pulling this together. Right, thank you all. I think we will close. Have a good rest of the week, everyone, and thank you very much again.
Likewise, everyone.
Okay.
Thank you.
Thanks. Bye-bye.